Hello everyone. Good morning. I hope you have a pleasant day. So my name is Kunj Shetia, and today I will present about what ArcGIS Spatial Analyst is. I will start with the presentation and further I'll move on to the demos. So what exactly ArcGIS Spatial Analyst is? It's basically a desktop extension which provides several spatial modeling and analysis tools. It is one of the oldest extensions with robust tools which can deploy or employ a wide range of data format to combine different types of data sets, interpret new data. We can get several insights from the existing data, elevation data or the raster data. Also, we can perform some complex raster operation with the help of spatial analyst extensions. So there are over 100 geoprocessing tools which are present in spatial analyst extension. It is a desktop extension which is available with ArcGIS Pro, and few of the functionalities are also present with in the ArcGIS Online in the ArcGIS Enterprise. So if I talk about the spatial analyst, what are its different benefits? Or I can say what are different types of use cases it can be in which it can be used. So I can say that I will start with the terrain analysis, where we are basically calculating the slope, the aspects, the contours, the hill shades. We are also calculating several viewshed analysis in our day-to-day geoprocessing analysis criteria in different types of domain. Further is the hydrological analysis. So it helps to gather the insights from hydrological and the landscape data. So it is basically used to model the flow of water. It helps to create the drainages, the watershed, the stream network, the stream order, the drainage density. In this, all the analysis can be performed with the help of hydrological analysis in the spatial analyst extension. Further, about the suitability. So we are always interested to find out some best locations or some vulnerable locations or the risky locations in an area. So with the help of spatial analysis tools, we are finding the ideal locations or the risk locations by considering several criteria which are related to demographics. It can be related to terrain also. It can be related to environment also. So from all these criteria, we are able to identify some best locations, or even I can say some vulnerable locations. Further, the interpolation analysis. So it helps to create a continuous surface from some kind of dispersed sample locations. Now, as we know, we can't collect the samples from each and every point of an area on the Earth surface. So we can use some interpolation techniques. So if you are interested to predict some values at some unknown locations, in that case, the interpolation analysis is very much important. Further, to identify some best routes. So here we can calculate some straight line distance between the 2 points, or we can add some weightages into it. So we can say some cost weighted distance surfaces can be generated to understand the cost of getting from one location to another, and based on some particular specific criteria also. Second, after doing several kind of analysis, like the suitability, the interpolation, the hydrological, finding some kind of best routes on the distances on a different terrain, then we are always interested to gain some insights. We are interested to gain some statistical information from these. So we can get some, for example, I'm interested to get some mean value for a particular crop yield for over 10 years of period or a decadal change. Then it can be identified with the help of statistical analysis within the spatial analyst, where we can use the zonal statistics tools also, where if we are interested to identify a mean elevation for a particular forest zone in a particular state or the district. So over there, we can identify we can gain some statistical insights in it. Further, moving on, which are the important tool sets to work on? So when we are talking about spatial analysis, there are several tools which are present within the spatial analysis, and those tools are very much important to do some day-to-day analysis within our GIS domain. So one is surface, which I talked about, that we use to quantify and visualize the terrain landform. The surface tools are basically deriving the insights related to the elevation models. Further, the map algebra. So we can do some kind of spatial analysis with creating some expressions in an algebraic language. The best tools we all know that is the raster calculator over here. The reclassify. So if you are interested to change some input cell values to alternate some different cell values, then we can use the reclassify tools. The reason to do is basically to replace the values based on some new informations or grouping of some kind, certain kind of values, reclassification of values to a common scale. So here the over in this type of scenarios, we are always going with the reclassification. Further is the solar radiation. So it helps to map and analyze the effects of sun over an area or a location for a particular time period. It also considers different types of obstacles also, the slope and aspect and everything. The hydrology, as I said earlier, to flow the water across to identify the, or I can say the model the flow of water across the surface. Zonal statistics, if I talk, then to statistics tool to identify the statistical information of a raster file for a particular any ROI or I can say a taluka or a district or a state for a particular feature class. So moving forward onto this, so I will first go with the terrain analysis. So what type of information can be derived from the DEM? So I can say that spatial analyst has several tools for extracting information from the digital elevation model. For terrain analysis, we need to have some kind of elevation data. So what we can do with it. So for example, if I am interested to have a good location for my new home to build, then I will look for a data where I have to generate an aspect and I have to identify the south facing locations. Further, if I am interested to install a solar power plant or a rooftop building, then how it can be done? Then we need to identify the solar power generated for that particular building by calculating the amount of solar energy that can be generated using the solar radiation tools. And further, we can take into account the slope or the aspect or the time of the day in which day of the year you are interested to consider you are interested to calculate the solar power. That can be done. Further, it can also consider the shadow effects which are generated from several types of obstacles present in the nearby areas. Also, we can derive the watersheds and the landscape characteristics with the help of the hydrological tools. So over here, you can see that several analysis screenshots which are present over here, where you can see the hillshed effect over here, the drainage density. You can see several different types of streams are present. The buildings over here, you can see that is basically the solar radiation, which has been calculated for particular building footprints. Further, the aspect, the curvature, the slope. So these types of analysis can be done with the help of the terrain analysis. Further, finding the best locations. As always, we are interested to find the best location. So I can say that what is the fundamental question of GIS is to find the one of the best sites or the most vulnerable sites. The problem can be referred to as the optimal site selection or a vulnerable site selection for a suitability model using the suitability model. So I can say the suitability model basically combines a set of layers which describe why the place is the best or how suitable or vulnerable that place is. So for example, if I'm interested to find some sites for landfill, we might need some areas which are flat or undeveloped and in the outskirts of a city, which are the best locations for the potential landfill sites. Further, likewise, if you are interested to find some suitable sites for some coffee plantation, then we need to go with some particular kind of soils in that particular region, and also how much rainfall that particular region is receiving. So it will help to understand which are the best location for a coffee plantation. Same way, if I want to identify some risky locations or some vulnerable locations which are related to poor water quality, then I need to identify those areas first of all. Then I need to identify how much population is over there, or how many health facilities are present over there. So from this, we can identify what type of sites what type of sites are vulnerable in that particular area. So how these layers can be combined? So these layers just can't be added. So we need an overlay suitability model technique in which we assign values as ranked numbers or percentage from 1 to 10 or from 1 to 100 to each raster, and also the classes within that raster, indicating that how suitable the layers are for the purpose of the modeling. So what type of layers can be used, or I can say what type of data layers or the parameters can be used. So land cover is one of the things, soil, rainfall, temperature, pressure, etc. And so these are basically several data layers which can be used for several kind of site suitability analysis. Interpolation technique, as I said earlier, to estimate the values at some new location, or I can say unknown locations, creating some continuous rasters, continuous raster surface, and generating the values from it. So sometimes we don't have the raster, and to solve our problems, we might only have some sparsely spaced samples. So from that, for example, if I have some 20 air quality station points in a city, and I'm interested to gain insights of the areas where I don't having any readings regarding the air quality. So with the help of interpolation tools, we can create such rasters, and with the help of the distance measured locations, accordingly, it will give the values for that particular area. Finding the best routes. So basically, we can say to find the optimal paths for a particular terrain. So there are some particular tools which helps to compute the distance from each cell to the nearest object or place nearby. These distance tools can be used to compute the distance to a nearest electrical grid in a wind farm site. So for example, if I'm interested to compute a distance to the nearest wind farm, then we have to go with the Euclidean distance or any certain kind of distance which will help to compute the distances to a particular wind farm. As the wind farms are situated on some kind of hilly terrain, or the areas which are away from the roads. So over there, we are interested to see that how we can reach to a particular wind farm. So in that way, the distance analysis tools are very much useful. Or else if we are interested to identify some protected areas also, then also the distance analysis tools are very much important. Further, to identify the best route for a particular wildlife corridor, so we can go with the cost weighted distances, which are the least cost path where the wildlife can travel from a particular patch of habitat to another patch of habitat. And these types of analysis can be done with the help of cost path analysis in the ArcGIS Pro Spatial Analyst Extension. Further, what are the new capabilities which are, or I can say new tools which are there in the spatial analyst in ArcGIS Pro? So one is the suitability modeler. Other is the multidimensional tools which are present. So multidimensional data is represent the geospatial data which is captured at multiple times, or I can say multiple depths. These types of data are commonly used or identified in atmospheric or oceanographic areas. And it is basically licensed with spatial analyst and image analyst also. There are several surface tools which are added, like the geomorphone landforms, the view shed. Other are basically the space-time kernel density, where we are calculating the relative position and magnitude of particular input feature, which includes both the dimensions, that is the time and the depth. Few of the added tools are basically related to solar analysis, like raster solar radiation tools. Also, the zonal statistics tools are present, but there are few more options, statistical options, which are being included, like the majority count, majority percentage, minority count, minority percentage. So these are the few of the capabilities which are enhanced with respect to the ArcGIS Pro Spatial Analyst Extension. Now let me move forward towards the demo part. So I explained about the different types of terrain analysis. And as you can see over here, this is an image, I can say a map which is open related to the Sabarmati Basin in Gujarat. So as you can see, this is my ArcGIS Pro, and in that I have added a DEM of basically a Sabarmati River Basin, and I'm interested to identify some curvature, some aspect, some slope. So that can be done with the help of the spatial analysis tools. So these are several surface related spatial analysis tools where I can identify this aspect, contours, the hillshade, the slope, the view shed, visibility. So there is a surface parameter tools over here within which you can identify, you can input your raster. You can select the parameter type, whether you are interested for a slope, aspect, or curvature. So no need to process individual tools for the creation of the data layers related to slope, aspect, or curvature. It can be done within the single tool for surface parameters, and accordingly it can run the process. So these types of tools, these types of layers are generated. Aspect is there, slope is there. Further, as I mentioned about the geomorphon landforms, so this is one of the tool which is present in ArcGIS Pro Spatial Analyst, where it will help you identify different types of geomorphic landforms within the DEM. So for example, I can input the raster, I can select the output, I can give certain types of search distance and the skip distance, and from this it will identify the geomorphon landforms. So basically combines the elevation differences and visibility concept to classify the terrain into different types of geomorphom landform types. So there are basically two parameters on which it works, basically the search distance and the skip distance. And it will help to gain some valuable insights for some kind of wildfire monitoring and also in the hydrology concepts. So for example, as you can see over here, this is one of the output which I have generated from the DEM, where you can see the blue areas or the blue lines which are present are basically the valley sections. The red ones are basically those areas having the ridges are there. So it will classify into different landform types, as you can see over here, which is the flat, peak, ridge, shoulder, foot slope is there, valley is there. So it will help to understand that what type of area is present in that particular terrain. So if, for example, if I want to establish a wildfire watchtower in a forest area, so these types of analysis will help that which are the ridge tips or peaks where I can put I can establish a watchtower for a wildfire to know the type of activities which is taking place in the forest. Further, if I'm interested to view that what type of terrain I can visualize from a particular point. So viewshed is one of the tool in which this types of analysis can be done. So we have a tool which is known as the geodesic viewshed, in which we can input the raster. We have to select certain points. I can say the observer points, and it will help to understand how much view, or I can say how much viewshed can be generated from that particular point. So I have selected a particular raster. I have selected this point over here, and I want to know that how much viewshed or how much visibility is present from this particular point. So I can give several parameters also over here, that how much surface offset is there, how much observer, what is the observer elevation, what is the observer offset. So this way it will help me to gain or a more detailed insights about the viewshed. And further, this can be visualized into a 3D scene within the ArcGIS Pro to understand the concept and the terrain into a 3D manner. Further moving on, I talked about the hydrology. So as we all know, there are several tools related to hydrology within the spatial analyst. So these are the several tools related to hydrology, like flow accumulation, direction, the stream link, stream order, the watershed generation. So this can be done with these tools. As you can see, I have calculated the stream order over here, and it will help to understand how the flow of water is taking place in particular basin, and to understand which are the areas which are accumulating more water in a particular terrain. Further, you can also create the contours, and you can identify certain recharge areas or the recharge station in that particular basin. Further, moving on this, let's talk about the solar radiation. So we are all interested nowadays that how the solar power will be helpful to generate free electricity in a particular area or in a particular building. So solar radiation tools are one of the tools where it helps to identify how much power, solar power can be generated on a particular building or a particular location, in which it considers the time of the year, in which year you are interested to generate the solar power. It considers the solar angle also, and also it considers the different types of obstacles which are present in that particular area. So for example, I have some data over here, which includes which includes a DSM along with the building footprints over here, as you can see. So further, uh, I'm interested to calculate some suitable rooftops over here. So with the help of the raster solar radiation tool, I have calculated the solar power, how much solar radiation is present in that particular each of the building footprints. So from that, this is the solar radiation output which I have got. And further, I want to identify which are the suitable rooftops. So there are certain criteria for it. So for example, one of the criteria is basically the slope should be less than 45 degrees. Further, it should receive more radiation in that particular rooftop. Further, the slopes, the orientation of slope should be not the north facing. So I can create those types of layers with the help of the conditioning tools within the spatial analyst, where I can give the conditions and further create the different rules and the clauses within it, and accordingly I will get some output on. So for example, I can input the raster over here. For example, as I said earlier, I am interested to remove the areas which are having high slope. So I can take a slope raster over here. I can put a clause and I can put a constant value. So for example, what you are seeing on the map over here is basically a raster with giving the value, with showing the values of the solar radiation in the areas which is having the slope of less than 45 degrees. Further, same way, I can also get the areas which is having the more solar radiation, receiving more solar radiation, and also further I can get the areas of the solar radiation with the solar radiation values where the slope is less than 45 degrees, which is having more radiation, and also these are the areas which are not towards the north facing. So as you can see over here, few of the building footprints which are having the solar radiation, which are showing some solar radiation, are being taken out. These are, it shows that whatever the conditional tools which we have ran, it shows that there are several obstacles which are present in this particular building footprints are being removed. Now further I'm interested that how much power is generated for a particular building. So I can use the zonal statistics tools over here, and I can say that which particular building is receiving what type of radiation in that particular area. So with the help of zonal statistics tools, I can create a mean for each and every building, and as per the area, it will give me that which building is receiving more solar power compared to the others. So buildings which are having a larger area, but obvious will receive a more solar power. Buildings which are having a lesser area will receive less solar power. But these are the buildings which are suitable to install a solar panels, or I can say which are suitable to generate a solar power in that particular buildings. Further, you can see, as I said earlier, these are the empty building footprints which is having some kind of obstacles or which are not fulfilling the particular criteria which we have defined. Further, moving on with with the spatial analyst. So I talked about the suitability analysis, the suitability scenario. So for example, I'm interested to create some vulnerable areas or the affected areas of a population which is affected by the poor water quality. So as we know that if there are certain contaminants in the water present, then it can lead to some kind of serious health issues. Particularly if there is a children present in that particular area and the water quality is not good, it will lead to serious health issues to those particular children, and it will be very much harmful to them. So we need to focus, or I can say this types of suitability, or I can say vulnerability site analysis will help the authorities to take a proper decisions where they can improve the water quality scenario. So for example, I have some input data over here where I have selected some sources, or I can say some treated water sources. What is the percentage of treated water sources? Also the how much healthcare facilities are present in particular state. What is the population, particularly what is the population under the age of 6, and also the what is the water quality scenario in that particular area. So over here, I have considered the fluoride, the content of fluoride in particular water. And if the content of fluoride in water is high, then it will lead to diseases related to bone. So how a suitability will work over here? So we all know that in past, we used to do the suitability analysis with the help of weightage analysis. The concept remains the same, but the approach of doing it bit changes. So in ArcGIS Pro, we have in the analysis ribbon, as you can see, this is a ribbon based interface. In the analysis ribbon, if you go, then you can see there is a suitability modeler tool present over here. If you select it, then accordingly on the right hand side, you can see the suitability modeler. You can name the model, what type of model input you are interested in, whether you're the criteria or the sub model, what type of scale you are interested in, what type of weightage you want to select, whether you want to go with the multiplier or the percentage. So I have gone with the percentage. Then moving forward, now is the part where we will select what type of layers we are interested to put in. So I have selected some particular 5 or 6 type of layers, and I have given them some amount of weightage. Now if I see over here, the percent total is 100. So it should not be less than 100 or the more than 100. So if I switch it, accordingly the percent total will change, and accordingly there will be changes over here in the map also. So I will change it again to 15, so the total will be 100. And you can see whenever you can see, then there are certain set of layers, data layers, which are present over here. And on the left hand side there are a few dots. There is a gray dot, there is a green dot. So green dot indicates that whenever that layer is selected in this transformation pane. If I select another data layer, then the dot will change. It will move to the treated water sources, which are present over here in the transformation pane. So whenever you select a layer, accordingly the changes will take place in this transformation. So in this transformation pane, it is designed in such a way that it will automatically detect which type of data layer it is, whether it is a categorical data, whether it is a classification data, or whether it is a continuous data. Further, you can select any of the type if you are interested within it, whether you want to go with the continuous data, whether you want to go with the classification data. In the continuous data, you can select certain kind of functions. Further, you can also give different types of threshold within it, what type of standard multiplier or mean multiplier you are interested in. So I have selected the classification data, and accordingly within that, I have given some suitability values to that, which are the areas which are more suitable within, or I can say which are the subclasses which are more suitable and which are less suitable. On the left hand side, you can see a histogram which shows the distribution of the entire suitability map. And on the right hand side, it shows the histogram of the current layer which is present in that particular transformation pane. If I select another layer, accordingly the histogram will change on the right hand side and even on the left hand side. So this way, it will generate an output over here on the map. You can see. So this is one of the model output which I have got. So as you can see, there are certain areas on the eastern part of the state and in the central part of the state where the problem, or I can say the vulnerable sites, are present in this particular area. Now, if you want to go into more depth into it. So if you are if you are interested to identify that how many square kilometer of area or how many 3 or 4 areas I want to identify within the entire state, then we can do it with the locate tab. In the locate tab, you can particularly assign which what is the output modeler, output of that particular modeler, total area. Like I have selected the 1000 square kilometer area, which are the risky locations having the areas of around 1000 square kilometers. I want 3 areas which consist of 1000 square kilometer area, and accordingly if I run it, then I will get some locations where this types of these are the locations where the vulnerability is maximum. So further, now I showed an entire overview that how different data layers can be used in a suitability, how that particular individual layer can be assigned a particular value for suitability, plus within the within that particular layer, if there are any subclasses, then those subclasses can also be valued. Now further, going forward into the same, if I am interested to evaluate each and every particular criteria within that suitability model, that can also be done with the help of evaluate pane. So within that suitability modeler over here above, you can see that open evaluate pane option is present. If I open it, then there are two maps which are present over here. And in that evaluate pane, there are two graphs or histograms which are there. On the right hand side, you can visualize the suitability map and the locate. So on the right hand side, you can say that in the suitability tab, in the evaluate tab, you can see that what is the model name, how many criteria I have selected, what is the weightage I have given to each and every criteria within it, what type of state or the values which are there. So this all the analysis and the statistics will be generated over here at what particular resolution you are working. Now further, I'm interested that within the suitability pane, there are certain points which are very much important to know. Like for example, there are 4 tabs over here: the overview, criteria, and summarize within. So overview will give the overall composition of the model, that the what is the histogram of the model, what are the statistics for a entire distribution of the site suitability modeler. It will also give the distribution or the statistics about the single criteria, individual criteria which are present. If I select any, then accordingly the changes will take place over here. That how the suitability values are distributed with respect to the treated sources within the criteria. Further, if I move forward, then criteria will give, it will help to explore the composition of the criteria and interaction within the model. So will take some time. Yeah. So for example, I'm interested for the raw input data or the transformed input data, how that particular the criteria is behaving. So if I apply it, then it will give me a distribution for a particular transformed input data for the water quality, and I can also calculate the same for the raw input data. Same way, now this is I'm getting the analysis for the entire state right now. But if you are interested for a particular watershed within that state, or a particular parcel or a particular taluka, then how it can be done? So with the help of summarized within tool, that can be those type of criteria and the decisions can be made. So basically, the suitability modeler over here demonstrates the true end-to-end experience from analyzing the data and finding the optimal locations or the risky locations in a particular state. The suitability modeler uses the same concept of weighted overlay, as I said earlier, which can be, but over here the case is that it is more user friendly and have an interactive dashboard and gives a rich experience within the ArcGIS Pro. Moving on to this, so we talked about the distance analysis. Now, for example, I'm interested to have to define some optimal path for a particular wildlife corridor. So as you can see, I have some data over here. There are some polygons present over here where I have some wildlife habitat given in the purple patches which are present over here. There are also data related to road. What is the land use, land cover, or the protected areas which are designed in this? Now from this, I want to identify which is the least cost path. With the help of using the least cost path, I want to identify which are the optimal locations or optimal paths for a wildlife habitat traveling or IK. So further, I had to define some cost surfaces from it. So I have defined a couple of few of the cost surfaces over here, where from the elevation data, I have identified the ruggedness of the terrain. So I can say that the red areas which are present are basically the areas with less slope, less ruggedness. So basically, these are the areas in the valley part particularly there is a lot of urbanization taken place in this particular red areas. In the green areas, basically the mountainous areas, which are very much suitable location for that particular wildlife. Further, the wildlife should be in those particular areas where the noise is, I can say, the disturbances are less. So these are the areas which is this cost surface shows that what is the distance to roads of the cost surface. So the red ones are the areas where the roads are heavily constructed, jam packed, and the green ones are the areas which are away from the roads. So this will help to understand that the areas which are away from the road are basically more suitable for a wildlife habitat. Same way, the land cover cost surface have been created where the wildlife which we are working is basically interested or more suitable in the areas where there is having a dense vegetation and some mountainous or the ruggedness in the terrain. So these are the green areas which are more suitable for a wildlife in that particular area. Further, what are the protected sites, or I can say which are the reserved forest in which the wildlife will be feel more protected or comfortable in those. So greener are those areas in which they are interested. Now, from these cost surfaces, we can identify which is the more optimal location to it. So I have built a border builder over here, where first I have identified with the help of distance accumulation tool in the distance analyst of spatial analyst, I have identified the distance to the road cost surface. From the elevation, I have identified the ruggedness within the focal statistics. With the reclassification tool, as I explained earlier, I have changed the land cover values to a different cost surface values, and also the same way I did for the protected status or the protected forest data layer. And further with the weighted sum, that is a kind of suitability tool where I have given some weightages to each of the values, and accordingly it will give me an output. So over here, as I said earlier, that this particular wildlife animal is interested in such a habitat where there is more mountainous, there is more ruggedness, plus it should be a dense vegetated. So I have given higher weightage to these two parameters, and accordingly an output surface is generated. So this is my output surface, the final cost surface I can say, which shows that the greener areas are more suitable to it. The red ones are the less suitable, and also the red ones are the areas which is having the higher urbanization and presence of the roads in it. Now from this, I want to identify that which is the best suitable path or best corridor to travel for a wildlife. So best corridor can be identified using the least cost analysis. So I have created the cost surface. In that cost surface, which are the low cost areas, which are the high cost areas can be easily identified. So further in it, I can say that which are the optimal paths, optimal corridors. So these are basically the optimal paths or the optimal corridors for the suitable wildlife corridor traveling. So with the help of spatial analyst in it, I have used the yes. So these are the optimal region connections. Over here, you have to input a particular raster layer. Further, you have to input the cost raster layer also. So this raster layer will be very much helpful in it. So using this cost surface, it will identify those areas, or I can say those cell value it will identify, which is having the least cost values. So this least cost value will help to indicate a particular path. In that particular path will be will be very much helpful to the animals, which is having the less stress, or I can say very less disturbance in that particular path. So for these are the paths, but the thing doesn't end over here. So these types of optimal path for wildlife can be prepared, and this, as I can say, there are several actions are needed further. So we can take a swath of a land over the proposed corridor path. So I can take a pairwise buffer analysis I can do over here, and I can take a particular path where I can say that this is a path where there should be no further development, as these are the suitable paths for the wildlife to travel from one place to another. Further going on to this, as I said earlier, there are certain set of new tools which are present in ArcGIS Pro Spatial Analyst Extension. So for example, now there is a tool which is known as space-time kernel density. We all know about the kernel density. We all know about the density analysis that can be placed. So for example, I have some particular set of points. I have some points in a city where how much crime is taking place in that particular area. So I have those points, and if I want to do some density analysis that can be done, it will help to gain an insight where which are the areas which are having higher crime rate. So it will give me at a raster layer which is showing a density where those particular areas are having a dense crime rate, whether there are areas which is having a less crime rate. So same type of approach can be used in space-time kernel density, but over here the only change is that we are going with or talking about the two dimensions, which is the time dimension and also the elevation or the depth dimension. So over here, I have a certain set of points where I am having some data related to fish identification in Indian Ocean. So I have a data where I have the event date also. I have some time at what time, what type of fish were identified. Also, I have at what depth or at what particular depth in meters I am getting the I'm identifying particular species of fish. This type of data I have. Along with it, with the help of ArcGIS Living Atlas, I have also got the data related to sea surface temperature for that particular time period. So I have attached that data with particular table, and further I have developed a raster layer in a I can say a multi-dimensional raster layer, which shows me that at what particular time, at what particular depth, the sea surface temperature has changed. So as you can see over here, if I select this layer, then I'm able to see a multi-dimensional tab over here. I can select particular data layers within it, and also I can select at what depth or what elevation depth I'm identifying those particular type of species. So this type of analysis and this type of multidimensional raster analysis will help to understand that in which particular or I can say a particular type of fish is more suitable in which particular depth and in which particular surface temperature. So if tomorrow there is a sea surface temperature change taking place in particular area of an ocean, then it will help to understand that those particular type of fish or species of the fish will be identified in that particular area. So overall, if I say the spatial analyst tool, so spatial analyst tools are basically the most common and I can say one of the oldest extension in ArcGIS Pro. It helps to understand the analysis related to the terrain, related to the hydrology. If you are interested to do some analysis related to interpolation, where we are interested to find out the values at places where are no sample locations present. Also, we are interested to do some multidimensional analysis, like we have some data related to time or related to depth with respect to the change in this on a spatial level. Then those types of analysis can be done with the help of spatial analysis related to solar radiation, analysis related to the zonal statistics. So this several types of analysis can be done with respect to the spatial analyst extension tools, and people are the GIS professional in several industries are working on it on day-to-day manner. So that's it from my side, guys. Thank you very much. If you have any question and answer, please you can ask.